My name. This was done in conjunction with my colleagues at. The motivation of this work is funneled by face recognition. Um, we also want to be able to have the interoperability with existing biometric databases, cooperative tactical scenarios. But the fundamental question that we have with visible spectrum imagery, three components: S0, S1 is the 0 degree and 90 degree components, and S2 is the 45 degree and minus 45 degree. There's also a fourth component, which for thermal imaging is often assumed to be 0 because it's difficult to measure. We use dense SIF features to extract features from the face image in each of the S0, S1, S2, and the visible. Then we exploit feature regression, the visible domain, and then we classify them. So dense SIF features give us a redundant representation, and it's meaningful for face recognition. It's a relatively new. Then for the feature regression, we explore two different paper presented in BMVC. But one of the downfalls that we found with that, an indirect regression approach known as a coupled neural network. And so again, instead of directly doing the regression, we map it to a common subspace such that the features from the visible are highly correlated. And then we have the global recognition that we're looking at results. So we were looking at overall our proposed framework. How does it compare against these individual state-of-the-art algorithms? The deep perceptual mapping, which was presented last year at BNV, algorithm, which was published in a journal paper previously. What kind of benefit do we get out of the polymetric imaging itself? In our learning scenario, we divided the equally. We have a very small data set. Like I said, the polymetric thermal imaging, very small data set, so we don't have a lot of data to train on. Over 100 trials, and for rank 1 identification rate, we achieved about 94% in our proposed framework, and then the best individual algorithm attained about 89% rank 1, and that was the coupled neural network. So in this left figure here, we compare the conventional thermal and with the polymetric improvement. And for the coupled neural network, we get 11. Improved the results for expression by 4.9%. So for conventional thermal. So not only is this approach get a improvement, and for polymetric thermal, 4%.